All right, this is another proof where it really helps to go from the given, see how far you can get, and then work your way backwards from the proof. And I want to eventually prove that it's an isosceles triangle, that ABQ is an isosceles triangle. So first I'm going to label what I have for the given. I know that QP is perpendicular to N, therefore, if it's perpendicular, if this guy's perpendicular to the plane, it's also perpendicular to AP and BP because they're in the plane and they travel through the foot, which is P. So that means I'm going to have a couple right angles there because they're perpendicular. Now, of course, I have to say all those steps in my proof. First, if they're perpendicular, you have right angles, and if I want to say that they're congruent, I can do that as well. So it might be a total of 3 steps there. All right, my next thing is the A and B are equidistant from P. Well, that just means that these guys are congruent here, nothing more than that. So that's everything for my given. How about my proof? Let's look at the proof, and I'm going to use blue for that one to say, hey, this isn't what we know yet, but it's what we want to know. If ABQ is isosceles, I know that these guys would have to be congruent, and my base angles would have to be congruent. So, is there any way I could prove that those base angles are congruent? Well, they're really not a part of 2 triangles. It's part of the one triangle, so let's see about the legs, if AQ and BQ. Well, I notice that AQ and BQ are both a part of this triangle here, and then the one that's behind it. Remember, this is a 3-dimensional figure, so you really have to think about it in 3 dimensions. It's not like a kite. I know some of you might think that it looks like a kite, but it's not. It's 3 dimensions. So you got this, this guy here. Who knows, maybe this is a good model for you to make for your extra credit. Okay, so I got these 2 triangles that I want to prove congruent. Well, right now I have 2 sides. I have angles that I know that can be congruent. I bet you I can get another side in QP. So now I have side, angle, side. I can prove the triangle is congruent and go from there. Why don't we do that? So, set up my proof. And again, on this one, I'm not going to write the given because I'm going to run out of room. This one's a little bit of a longer step, so we'll start on the second step. It's a little longer proof. And why don't we just go with the fact that AP and BP are congruent. AP is congruent to BP, definition, congruent. Because they're equidistant, they have the same length, that means that they're congruent. All right. Step 3. I know that QP is congruent to QP. Reflexive. All right, now let's go to the angles that we were talking about. So we know that QP is perpendicular to AP, and that QP is perpendicular to BP. And that would be one of the reasons we use in many of our proofs. If a line is perpendicular to a plane, then the line is perpendicular to any line in the plane. All right. So, if they're perpendicular, then we know we have right angles. So angle APQ and angle BPQ, right angles. Def, perpendicular. So angle APQ is congruent to angle BPQ because all right angles are congruent. So now what I have is a pair of sides congruent, pair of angles congruent, pair of sides congruent. I can do this by side, angle, side. So triangle APQ is congruent to triangle BPQ by side, angle, side. A couple more steps here. All right, so that means that AQ is congruent to BQ, as we have there in our, we outlined that in blue because we wanted to prove that, and that's by CPCTC. And then lastly, triangle ABQ is an iso triangle, and that's by definition iso triangle.